Question 5, JAMB 2017 Chemistry. The bonding between water molecule and hydrogen ion is. First thing I want us to know is the configuration of a water molecule looks somewhat like this. And the water molecule consists of 2 atoms of hydrogen and an atom of oxygen bonded together as the case may be in a polar covalent dative bond. And for hydrogen water molecule binding, 2 pairs of electrons are shared. That could be found somewhere here. And that makes it dative. So if we go back to our options, the correct answer to this question is option A, which is dative bond. In the presence of water, sulfur 4 oxide is a strong reducing agent due to the formation of. This is question number 8 of the JAMB 2017 chemistry exams. And the correct answer to this question is option B, which is SO3 2- ions. So in the presence of water as seen in this equation, SO2 will simply react with water to give us H2SO3. And if we dissociate this, we're going to be having hydrogen ions and SO3 2- ion. So that buttresses the fact that the correct answer to this question is SO3 2- ions. Question number 10 of the JAMB 2017 chemistry exams. In the diagram, the salt that is independent of temperature is. The first thing I want us to know is this is a diagram illustrating the solubility of salts or substances with temperature. So if we look at this diagram critically, we can deduce the following: that CaOH subscript 2 is calcium hydroxide, rises and falls with increase in temperature, and there is a minimal increase in solubility as temperature increases for sodium chloride, and there is a rapid increase in solubility with increase in temperature for KCl. And for KClO3, its curve is independent of the temperature change, as we can see here. So the only salt there that is independent of temperature is KClO3, as seen in the diagram. Question number 22 of the JAMB 2017 chemistry exams is what we're looking at. The equation illustrates the manufacture of. What I want us to know about this question is we can look at the diagram or the equation above and rewrite it as follows. So what we have here, CH2 double bond CH2, is simply what I've written here as ethylene. This is a free radical polymerization reaction in which, under the influence of high temperature and pressure and an initiator, ethylene monomers are joined together to form polythene. And so what happens is, when this initiator splits into free radicals, it actually initiates the binding of ethylene monomers together, thereby forming a polymer known as polythene. So the reaction above, or the equation, illustrates the manufacture of polythene as shown below. JAMB 2017 chemistry exams, question number 23. When an unknown salt was warmed with copper turnings and few drops of concentrated tetraoxosulphate 6 acid, which of these ions will be obtained? The correct answer is option C, SO4 2- ions. So we can see that in this reaction, when we react copper with concentrated tetraoxosulphate 6 acid, we're going to be having SO2, Cu subscript 2SO4, and water. And so when we dissociate this, we're simply going to be having copper ions and SO4 2 minus ions. Question 27, JAMB Chemistry Exams 2017. The relative molecular mass of an alkyne with 6 carbon atoms is. First thing I want us to know is alkyne has the formula CnH2n-2. And so if we have the molar mass of carbon to be 12 multiplied by the number of carbon atoms, which is 6, plus 2 multiplied by 6, that is 2 multiplied by n, which is 6, minus 2. We're simply going to be having 72, that is 12 multiplied by 6, plus 2 multiplied by 6 minus 2, which is 10. That will simply give us 82. Therefore, the relative molecular mass will be 82. Question number 28 of the JAMB 2017 chemistry exams, what we're looking at. In the diagram, concentrated tetraoxosulphate 6 acid is used to. This is a diagram illustrating the production of chlorine gas. So what happens is, when the chlorine gas has been obtained, it is passed through H2O to remove hydrochloric acid, and thereafter pass through concentrated H2SO4, that is concentrated tetraoxosulphate 6 acid, to remove traces of water. Therefore, we can say that H2SO4 is used to dry the gas or remove water from the gas. Which of the following atoms contain the highest number of electrons in the outermost shell? This is question number 32 of the JAMB 2017 chemistry exams. The correct answer to this question is option D, which is neon. So let us look at why neon is our correct answer. We are presented with 4 elements: magnesium, silicon, fluorine, and neon. In the first element, we have the electronic configuration to be 2A2, that is, magnesium has 2 electrons in the outermost shell. Silicon has 4 electrons in the outermost shell. Fluorine has 7 electrons in the outermost shell. And neon has 8 electrons in the outermost shell. So this has the highest number of electrons. Therefore, our answer is D. Question number 37 of the JAMB 2017 chemistry exams. Hot compressed air blown into the inner pipe during the extraction of sulfur will. We're given 4 options in this question. But before we choose our answer, the first thing I want us to do is to look at this. So one of the processes used in the extraction of sulfur is the flash process. So in this process, 3 pipes are used. 3 concentric pipes are used. So for the first pipe, what happens there is superheated water at 165 degrees Fahrenheit is blown into the first outer pipe, and to the third pipe, compressed hot air is blown into it. So the question is, what happens to the second pipe? So the actions of the first pipe, or what has been done to the first pipe and the third pipe, actually pushes molten sulfur and water into the middle pipe. So from this explanation, it is obvious that the answer to this question is option D, which is to force the molten sulfur and water through the middle pipe. Question number 38 of the JAMB 2017 chemistry exams. The basicity of propanoic acid is. This is a question on acid and bases. But the first thing I want us to know is basicity is simply the number of replaceable hydrogen ions. In other words, we can say the number of moles of hydrogen ions liberated in an aqueous solution by 1 mole of an acid. For propanoic acid, which is given by the formula C3H6O2, we can deduce from the molecular formula that The number of moles of hydrogen ions that can be liberated in an aqueous solution by 1 mole of propanoic acid is simply 1. So if we go back to our options, the answer here is simply option C, which is 1. Question number 39 of the JAMB 2017 chemistry exams. In the electrolysis of dilute copper 2 chloride using copper cathode and carbon anode, the resultant effect on the electrolyte will be. Correct answer to this question is it becomes acidic. For us to solve this kind of problem, I want us to look at these reactions that for electrolysis to take place, we must have positive side called anode and the negative side called cathode. And for the electrolysis of copper 2 chloride diluted, if we dissociate this, we're going to be having copper ions and chloride ions on this other side. So over time, as the reaction proceeds, there's going to be switching of ions. So the positively charged copper ions will move to the cathode and the negatively charged chloride ions moves to the anode. And in this reaction, we're going to be having this as the total reaction. So we have chloride ions losing electrons to become negatively charged. And so you can see that here in this reaction. And we also have the copper ions gaining electrons to be neutral. And because of the affinity chlorine has for copper, being a metal, the overall reaction is still going to be giving us copper 2 chloride as a product. And all of these reactions, when a copper cathode is used and a carbon anode used, is going to be acidic. Question 40 of the JAMB 2017 chemistry exams. The element whose electron configuration is depicted below is. The first thing we need to do to solve this kind of problem is to rewrite this configuration. So if we rewrite this configuration, we're going to be having something like 1s2, 2s2, and 2p4. That is, we have 2 arrows in the first box, 2 arrows in the second box, 2 in the third box, 1 and 1 in the fourth and fifth box. And so if we add the powers all together, 2, 2, and 4, we're going to be having 2 plus 2 plus 4, and that is 8. So the question now is, which of the elements in the periodic table has atomic number of 8? And the answer is oxygen. And so, in this diagram, the electron configuration depicted below is that of oxygen.